A multi-wire branch circuit requires careful consideration when sizing the neutral conductor. The question revolves around whether the neutral wire needs to be larger than the ungrounded conductors in a specific configuration. Article 210.4c of the National Electrical Code, NEC, addresses this directly. It generally mandates that the grounded, white, wire in a multi-wire branch circuit must be the same size as the ungrounded, black, conductors. In the scenario described, these are number 12 THHN wires. However, the NEC does provide an exception under Article 210.4e that allows for a smaller neutral conductor under specific conditions. Let's break down the general rule and the exception. Firstly, the general rule states that the neutral must be the same size as the ungrounded conductors. This ensures that the neutral can safely carry the maximum potential return current from all the ungrounded conductors. Secondly, consider the exception outlined in Article 210.4e. This exception allows the neutral conductor to be one size smaller than the ungrounded conductors if these conditions are all met. 1. The ampacity of the neutral conductor is not less than the sum of the neutral currents of the branch circuit supplied by the neutral conductor. This means that the neutral must still be capable of handling the actual current it's expected to carry. 2. The neutral conductor is terminated in a neutral bus in the panel board or switchboard. This ensures a proper and safe connection for the neutral. 3. The neutral conductor is not connected to the grounded conductor on the supply side of the system. This prevents unwanted current flow and potential hazards. Now, let's relate this back to this specific situation. There are 320 amp single-pole branch circuits, using number 12 THHN wires. The concern is that the theoretical maximum ampacity in the grounded, white, wire could be 16 times 3 equals 48 amps. It is important to note that this is a theoretical maximum. It assumes that all three branch circuits are operating at their full 20 amp capacity simultaneously. In reality, this is often not the case. To determine if the number 12 THHN white wire is adequately sized, you need to calculate the actual load on the circuit. This involves determining the actual current draw of the devices connected to each of the three branch circuits. Once you have the actual load, compare it to the ampacity of the number 12 THHN wire. You can find the ampacity of different wire sizes and types in NEC Table 310.15b16. If the actual load exceeds the ampacity of the number 12 THHN white wire, it must be replaced with a larger size wire to ensure safety and code compliance. Additionally, it is critical to verify that the neutral conductor is properly terminated. Confirm that it is connected to a neutral bus in the sub panel and that it is not connected to the grounded conductor on the supply side of the system. In summary, while the NEC generally requires the neutral conductor to be the same size as the ungrounded conductors in a multi-wire branch circuit, an exception exists that allows for a smaller neutral under specific conditions. The key is to accurately calculate the actual load on the circuit and ensure that the neutral conductor has sufficient ampacity to handle that load safely. Also, double-check to verify proper termination of the neutral conductor. Always refer to the latest edition of the NEC and consult with a qualified electrician to ensure compliance with all applicable codes and regulations. Remember that electrical work can be dangerous, and safety should always be the top priority. Understanding the principles of multi-wire branch circuits and proper conductor sizing is essential for safe and efficient electrical installations. In applying the NEC guidelines, remember to consider the specific application, the expected load, and the conditions of use. This careful assessment will help determine the appropriate neutral conductor size for a multi-wire branch circuit. The NEC provides tables and guidelines for determining ampacity based on wire size, insulation type, and ambient temperature. Consulting these resources will ensure that the selected conductor is suitable for the intended application. Multi-wire branch circuits can be an efficient way to supply power, but they require a thorough understanding of the NEC requirements. Paying attention to conductor sizing, termination methods, and safety precautions is essential for a safe and reliable electrical system. The concept of ampacity is central to conductor sizing. Ampacity refers to the current, in amps, that a conductor can carry continuously under specified conditions of use without exceeding its temperature rating. The NEC provides ampacity tables for various conductor types and sizes, taking into account factors such as insulation type, ambient temperature, and the number of conductors in a raceway or cable. When selecting a conductor size, it is crucial to consider the expected load on the circuit and the ampacity of the conductor. The conductor must have an ampacity equal to or greater than the non-continuous load plus 125% of the continuous load. A continuous load is defined as a load that operates for 3 IOs or more at a time. In the context of multi-wire branch circuits, the neutral conductor carries the unbalanced current from the ungrounded conductors. In a balanced system, the current in the neutral conductor would be zero. However, in most real-world scenarios, the loads on the different phases of the circuit are not perfectly balanced, resulting in current flow in the neutral conductor. The NEC requires that the neutral conductor be sized to carry the maximum unbalanced load. This ensures that the neutral conductor can safely handle the current without overheating or creating a fire hazard. In some cases, the NEC allows for a reduction in the size of the neutral conductor for certain types of loads, such as electric ranges and clothes dryers. This reduction is based on the assumption that these loads are not fully balanced and that the neutral current will be less than the full load current. However, it is important to carefully consider the specific requirements of the NEC and the characteristics of the load before reducing the size of the neutral conductor. The termination of conductors is also a critical aspect of electrical safety and performance. Proper termination ensures a reliable electrical connection and minimizes the risk of overheating or arcing. The NEC specifies requirements for the type of connectors and termination methods that are permitted for different conductor types and sizes. It is important to use connectors that are listed and labeled for the specific application and to follow the manufacturer's instructions for installation. When terminating conductors in a panel board or switchboard, it is important to ensure that the conductors are properly identified and that the connections are tight and secure. Loose connections can cause overheating and arcing, which can lead to equipment failure or fire. The NEC also requires that conductors be protected from physical damage. This can be achieved by installing the conductors in raceways such as conduit or electrical metallic tubing, or by using cables with a protective outer jacket. In areas where the conductors are exposed to physical damage, additional protection may be required, such as installing guard strips or enclosures. Electrical safety is paramount when working with multi-wire branch circuits. It is important to follow all applicable codes and regulations and to take the necessary precautions to prevent electrical shock and fire. Before working on any electrical circuit, it is essential to de-energize the circuit and verify that it is dead using a voltage tester. It is also important to wear appropriate personal protective equipment, such as insulated gloves and safety glasses. Never work on electrical circuits while standing in water or on a wet surface. Water is a good conductor of electricity and it can significantly increase the risk of electric shock. If you are not comfortable working on electrical circuits, it is best to hire a qualified electrician. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in accordance with all applicable codes and regulations. In addition to following the NEC requirements, it is also important to consider the specific requirements of the local electrical code. Local codes may have additional requirements or restrictions that are not covered by the NEC. It is important to consult with the local electrical inspector to ensure that your electrical work complies with all applicable codes and regulations. Multi-wire branch circuits can be a complex topic, but with a thorough understanding of the NEC requirements and proper installation practices, they can be a safe and efficient way to supply power. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns. When examining the specifics of NEC Article 210.4e, which allows for the reduction in size of the neutral conductor, understanding the conditions that must be met is critical. Firstly, the ampacity of the neutral conductor must not be less than the sum of the neutral currents of the branch circuits supplied by the neutral conductor. This condition ensures that the neutral conductor is adequately sized to carry the maximum unbalanced current that it is likely to encounter. To determine the sum of the neutral currents, it is necessary to analyze the loads connected to each of the branch circuits and to calculate the amount of current that will flow back on the neutral conductor. This calculation should take into account the type of load, the voltage, and the power factor. Secondly, the neutral conductor must be terminated in a neutral bus in the panel board or switchboard. This condition ensures that the neutral conductor is properly connected to the grounding system and that it has a low impedance path back to the source. A neutral bus is a dedicated terminal strip in the panel board or switchboard that is specifically designed for terminating neutral conductors. Thirdly, the neutral conductor must not be connected to the grounded conductor on the supply side of the system. This condition is intended to prevent circulating currents from flowing in the grounding system. Circulating currents can cause voltage drops, equipment malfunction, and even fires. The grounded conductor, also known as the equipment grounding conductor, is the conductor that is used to ground non-current carrying metal parts of electrical equipment. It is typically a green or bare copper wire. The neutral conductor should be kept separate from the grounded conductor to prevent these circulating currents. In applying these conditions, it is important to consider the specific characteristics of the electrical system and the loads that are connected to it. A qualified electrician can help to determine whether the conditions for reducing the size of the neutral conductor are met and to ensure that the electrical system is installed safely and in accordance with all applicable codes and regulations. When calculating the actual load on a circuit to determine the required ampacity of the neutral conductor, several factors must be taken into account. Firstly, the type of load must be considered. Different types of loads have different current characteristics. For example, resistive loads such as heaters and incandescent lamps have a constant current draw. Inductive loads such as motors and transformers have a current draw that varies with the load. Capacitive loads such as capacitors and electronic devices have a current draw that leads the voltage. Secondly, the voltage of the circuit must be considered. The voltage is the electrical potential difference between 2 points in the circuit. The higher the voltage, the lower the current required to deliver the same amount of power. Thirdly, the power factor of the load must be considered. The power factor is a measure of how effectively the load uses the electrical power. A power factor of 1 indicates that the load is using all of the electrical power. A power factor of less than 1 indicates that the load is using only a portion of the electrical power. The formula for calculating the actual load on a circuit is as follows: load equals voltage times current times power factor. Once the actual load has been calculated, it can be compared to the ampacity of the neutral conductor to determine whether it is adequately sized. If the actual load exceeds the ampacity of the neutral conductor, the conductor must be replaced with a larger size conductor. The ampacity of a conductor is determined by its size, material, insulation type, and ambient temperature. The NEC provides tables that list the ampacity of different conductors under various conditions. It is important to consult these tables to ensure that the selected conductor is adequately sized for the application. In addition to calculating the actual load, it is also important to consider any future loads that may be added to the circuit. The neutral conductor should be sized to accommodate these future loads. It is also important to consider any deterring factors that may apply. Deterring factors are used to reduce the ampacity of a conductor when it is installed in certain conditions, such as when it is bundled with other conductors or when it is exposed to high temperatures. Deterring factors are specified in the NEC. When selecting a neutral conductor for a multi-wire branch circuit, it is important to consult with a qualified electrician. A qualified electrician can help to determine the actual load on the circuit, select the appropriate conductor size, and ensure that the electrical system is installed safely and in accordance with all applicable codes and regulations. Remember that electrical work can be dangerous and that it is important to take all necessary precautions to prevent electrical shock and fire. In summary, multi-wire branch circuits offer efficiency but demand meticulous attention to neutral conductor sizing and compliance with NEC. Always prioritize safety, calculate actual loads accurately, and consult with qualified professionals to ensure a reliable and safe electrical installation. When working with electrical systems, including multi-wire branch circuits, it's critical to prioritize safety above all else. Always to energize circuits before working on them using appropriate lockout-tagout procedures to prevent accidental re-energization. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. Never work on electrical systems in wet or damp conditions. If you are not qualified or comfortable working on electrical systems, always hire a licensed electrician. A licensed electrician has the training, experience, and knowledge to perform electrical work safely and in compliance with all applicable codes and regulations. They can properly assess the load requirements of the circuit, select the appropriate conductor sizes, and install the wiring and equipment correctly. Attempting to perform electrical work without the proper qualifications can be dangerous and can lead to serious injury or even death. It can also result in damage to property and violations of electrical codes, which can carry significant penalties. When inspecting or troubleshooting electrical systems, use appropriate testing equipment such as multimeters and voltage testers. Ensure that the equipment is properly calibrated and in good working order. Follow the manufacturer's instructions for using the testing equipment. Be aware of the potential hazards of working with electricity such as electric shock, arc flash, and arc blast. Take precautions to minimize these risks, such as wearing appropriate personal protective equipment and maintaining a safe distance from energized equipment. When making connections, use approved connectors and termination methods. Ensure that the connections are tight and secure to prevent overheating and arcing. Follow the manufacturer's instructions for installing the connectors and terminations. Properly identify all conductors and components. Use color coding or labeling to distinguish between different conductors, such as hot, neutral, and ground wires. Label all circuit breakers and other components to indicate their function and the circuits they serve. This will make it easier to troubleshoot and maintain the electrical system in the future. Keep electrical panels and equipment clear of obstructions. Maintain adequate working space around electrical panels and equipment to allow for safe access and maintenance. Do not store flammable materials near electrical equipment. Regularly inspect electrical systems for signs of damage or wear. Look for frayed wires, loose connections, cracked insulation, and other potential problems. Address any issues promptly to prevent them from escalating into more serious problems. Keep accurate records of electrical work performed, including wiring diagrams, load calculations, and inspection reports. This documentation will be valuable for future maintenance and troubleshooting. Follow all applicable codes and regulations. The electrical codes are designed to ensure the safety of electrical systems and to protect people and property from electrical hazards. Stay up to date on the latest code requirements and ensure that all electrical work complies with these requirements. By following these safety practices, you can minimize the risks associated with working with electrical systems and ensure the safety of yourself and others. Remember that electrical safety is everyone's responsibility. It is important to be aware of the potential hazards and to take precautions to prevent accidents. The number 12 THHN wire has a certain ampacity rating, but this rating can be affected by several factors. One factor is the ambient temperature. If the wire is installed in an area with high ambient temperature, its ampacity must be derated to prevent it from overheating. The NEC provides tables that specify the derating factors for different ambient temperatures. Another factor is the number of current carrying conductors in a raceway or cable. If multiple current carrying conductors are installed in the same raceway or cable, their ampacity must be derated to prevent them from overheating. The NEC provides tables that specify the derating factors for different numbers of current carrying conductors. It is important to consult these tables and apply the appropriate derating factors to ensure that the wires are adequately sized for the application. In addition to the derating factors, it is also important to consider any voltage drop that may occur in the circuit. Voltage drop is the reduction in voltage that occurs as electricity flows through a wire. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 5%. To minimize voltage drop, it is important to use wires that are large enough to carry the current without excessive resistance. You should also minimize the length of the circuit. When calculating the required wire size, it is important to use the correct voltage drop formula and to take into account the length of the circuit, the current, and the resistance of the wire. In summary, selecting the correct wire size for a multi-wire branch circuit involves considering the ampacity of the wire, the dirting factors, the voltage drop, and all applicable codes and regulations. Consulting with a qualified electrician is recommended to ensure that the electrical system is safe and reliable. The conditions of use of the conductors also play a critical role in determining their ampacity. Factors such as exposure to moisture, chemicals, or physical damage can all affect the performance and lifespan of a conductor. When selecting conductors for a particular application, it is important to consider the environment in which they will be installed and to choose conductors that are suitable for those conditions. For example, if the conductors will be exposed to moisture, it is important to use conductors that are rated for wet locations. If the conductors will be exposed to chemicals, it is important to use conductors that are resistant to those chemicals. If the conductors will be exposed to physical damage, it is important to use conductors that are mechanically protected. The NEC provides guidance on selecting conductors for different conditions of use. It is important to consult the NEC and to follow its recommendations to ensure that the conductors are installed safely and reliably. In addition to the NEC, there may be other applicable codes and standards that must be followed. For example, local building codes may have additional requirements for electrical installations. It is important to be aware of all applicable codes and standards and to comply with them. Failure to comply with applicable codes and standards can result in fines, penalties, and even legal action. It can also create unsafe conditions that could lead to injury or property damage. When in doubt, it is always best to consult with a qualified electrician to ensure that electrical work is performed safely and in compliance with all applicable codes and regulations. In conclusion, multi-wire branch circuits can be a valuable tool for distributing power efficiently, but they require careful planning and execution to ensure safety and code compliance. Pay close attention to neutral conductor sizing, ampacity calculations, dirting factors, voltage drop, and conditions of use. Always consult with qualified professionals and adhere to all applicable codes and regulations. By doing so, you can create a safe and reliable electrical system that meets your needs.